Good morning, everyone. My topic is fashion transformation of the bamboo fabrics for sustainability. Myself, Dr. Kavita Chaudhary, Associate Professor, Bansi Vidyapeeth, Rajasthan. First, ancient use of the bamboo extracting in India. Such as annual festival of the Kotiyar Mahadev temple of the Kerala. The handicrafts bamboo artifact know local name as adobo flower. Adobo flower. Adobo flower used for god and made by Indian reed bamboo. Indian reed bamboo very slim and small stem. Indian reed bamboo used ancient and written in Indian Puran. Or very interesting. Bamboo, which is also known as regenerated bamboo, is a regenerated cellulose fiber. In the last few years in the world market, more and more products from bamboo fibers have been appearing. It is market has having exceptional properties such as superior comfort and hand, as well as antibacterial properties. These are suitable for hygienic products and sanitary materials, sanitary napkins, absorbing pads, mats, bandage, and surgical gowns. Currently, regenerated bamboo fiber are used in apparel, including undergarments, sports, t-shirts, and socks, such as hosiery and knitted fabrics. Yarns of bamboo fiber provide the desirable properties of tensile, high moisture absorbency, antimicrobial and antifungal, sign and smooth close to silk, high permeability and thermal regulating property in textile and made-ups. In their collection, designers often replace more expensive materials like cashmere or silk, and including that the strength of bamboo fiber was equivalent to that of glass fiber. Bamboo fiber has found its way into the fashion world. So, the present study in a step in this direction. Objective: first, comparative study of the bamboo silk and cotton silk fabrics. Sub-objective to develop cotadoria fabrics from mixture of bamboo silk and cotton silk yarns. Construction of the fabrics. Two types of cotadoria fabrics were manufactured, in which bamboo, cotton, and silk yarns were used to prepare khat. First bamboo and silk, second cotton and silk. 54 nm single cotton and 64 nm bamboo counts were used, and 332 nm count of silk yarns were used. Or each khat make 14 threads, as 8 of cotton and bamboo and 6 of silk yarns were used, both side warp and weft. 300 to 350 cuts across the 46-48 inches width of the fabrics. Develop of the cotadoria on the pit loom used 100 reed count with plain weave. Cotadoria fabric. Cotadoria is a handloom made up of cotton, bamboo, and silk, which is known for its special weaving style that make the final fabric transparency, light, airy, and comfort feeling makes its first choice for the summer. It is also properly known as Masuria Malmal. Cotton silk is most popular combination of cotadoria. The warp and weft use a combination of 60% cotton and 30% silk yarns. This creates a fine square checks patterns. checks are properly known as khat. Weaving process. First make bobbing and then make krill filling and bag warping, sizing rice powder and onions juice for warp yarns strength, warp knotting and then weaving. To determine selected properties to developed fabrics. Properties of fibers. Fabrics low stress mechanical properties. Low stress mechanical properties such as compression, tensile, shear, bending, and surface properties were measured to axis hand of the fabrics. These parameters were entered into the Kawabata evaluation system to calculate primary and total hand value. Compression properties. These bamboo silk cotadoria and cotton silk cotadoria. Bamboo silk cotadoria high than cotton silk cotadoria. Fabric weight and thickness. Bamboo silk cotadoria, cotton silk cotadoria slightly difference both fabric. Tensile properties. Bamboo silk cotadoria fabrics and cotton cotadoria fabrics high than bamboo silk cotadoria fabrics. Shear properties. Shear properties, cotton silk cotadoria high and then bamboo silk cotadoria fabric. Bending properties and bamboo silk cotadoria and cotton silk cotadoria minor slight difference. Surface properties. Bamboo silk cotadoria and cotton silk cotadoria slightly difference. Primary and total hand value. Primary or total hand value, bamboo silk or cotadoria and cotton silk cotadoria nearest resultant. Freeze recovery of the fabric. Bamboo silk higher than cotton silk fabric. Comfort properties. First, air permeability of the fabric. Air permeability higher bamboo silk cotadoria fabric than cotton silk fabric. Thermal resistance of the fabric. Bamboo silk fabric low and cotton silk fabric high than bamboo silk fabric. Motion management properties of the fabric. Bamboo silk and cotton silk almost same. Last, drape coefficient. Bamboo silk higher than cotton silk fabric. Color strength of the dyes. Color dyes, synthetic dyes, reactive dyes, azoic dyes, and pigment dyes. Bamboo silk fabric higher than cotton silk fabric. Washing fastener properties of the fabric. Bamboo silk and cotton silk almost same. Rubbing fastener properties of the fabric. Bamboo silk and cotton silk almost same. And light fastener properties of the fabric. Bamboo silk and cotton silk fabric almost same. Comparative study of the natural dyes and printing bamboo and cotton fabrics. Natural dyes and printing process. First scouring, liquid ratio 1.50 of the and time duration 60 minutes, or casting soda 5% weight of the fabric and common salt 2% weight of the fabric. Natural dyeing and printing process. Preparation of the dye. Molding, weight of the fabric as a alum 10 to 20% and cetones 10 to 20% and 60 to 80 degrees Celsius for 60 to 60 minutes with material to require ratio 1.30. After moderating, the sample were rinsed in cold water to remove the excess of mordant and used for dyeing. Dyeing solution was boiling for half hours at 40 degrees and filter dye bath. After that, dyeing of the pre-mordanting samples was prepared of 1 hour at 40 degrees to 50 degrees Celsius in an open bath beaker dyeing machine at 30 ratio 1 liquid to material ratio. The dyed sample were rinsed in cold water and dried in open air. Procedure of the dyeing process. Preparation of the printing. Preparation of the dye printing. All the dyes used were first converted to powder form. 4 natural dyes were first dyed in oven at 50 Celsius for 24 hours and later grinding in mixer grinder. The powder so obtained was filtered through the system as linol fiber. The fine powder of natural dyes was used for printing. Guar gum being Norvinic is best site for textile printing. The stock paste of guar gum was prepared using 2% of guar gum powder. The guar gum powder was sprinked slowly in water with continued stirring in the odor to prevent lump formation. The paste was stirred continuously at 90 degrees Celsius for 1 hour for preparation of 1% of print paste. 1 gram of the dye powder was first paste with small quantity of water flow by adding of 99 grams of guar gum stock paste. The mordanting bamboo fabric were then printed with 2 strokes of squeegee steams and 102 degrees Celsius for 10 minutes. The sample were washed with water and then dried in air. Procedure of the printing. Color obtained bamboo fabric and cotton fabric. Japropic cotton good and bamboo very good, resulting observe of the color, and marigold cotton good, fair and good, or bamboo good. Apsara yellow fair, cotton fair and bamboo good. Primrose yellow, cotton good and bamboo very good. Indigo blue, cotton good and bamboo very good. Garnet, cotton good and bamboo very good. Sun yellow, cotton fair and bamboo good. Candy orange, cotton very good and bamboo excellent. And sarar yellow, cotton good and bamboo very good. Wine red, cotton good and bamboo very good. And turkey red, cotton red and bamboo very good. Brown red, cotton fair and good, bamboo very good. Katak silver, cotton fair and good or bamboo very good. Onion peel, cotton very good and bamboo excellent. Comparative study of the digital printing, bamboo and cotton fabrics. Digital textile printing is distinct as any inkjet based method of printing colorant into fabric. Conclusion: in the present era of fashion awareness and modernization, taste and preference of the consumer change rapidly. They demand variety in clothing. Creating something new is in need of for the apparel industry, and they are aware of it. Crease recovery of bamboo silk is slightly higher than that of cotton silk fabric, and 100% drape coefficient of bamboo silk fabric is higher than that of cotton silk fabric. This is due to reason that bending rigidity of cotton silk fabric is more than that cotton silk fabric. Air permeability of the cotton silk fabric was higher than that of cotton silk fabric. Where the thermal resistance was less, motion management of the both the fabric was almost same. Color fastness to washing fastness to washing, light and rubbing fastness has been measured. KBS value of cotton bamboo silk cotadoria is slightly higher than cotton silk cotadoria. Washing, rubbing, light fastness of the both fabric has been rated same. Cotton silk fabric exhibited higher Nuri smoothness, Fukurami fullness and softness, flexibility lower cosi than bamboo silk fabric. Some natural dyes was washing fastness fair in excellent and digital printing also both fabric bamboo and cotton was same. It is be concluded that bamboo have used as replacement of cotton yarn. Bamboo fiber has got unique combination of properties and it used to make appearance, home furnishing products and textile based products in medical appearance. Some value addition product color and effect techniques and scarf, plazo, extra wrap technique, round apron skirt, double cloth techniques stole, and ikat technique, blue top. Thank you.